Hello, everyone. Welcome back to the AAS YouTube channel. And this is part of the Sky and Telescope series. And I am super happy to have Sky and Telescope author and observer extraordinaire, Steve Gottlieb, with us today. Hi, Steve.
Hi, Frank. Thanks for that very nice introduction.
I think you particularly maybe like the extraordinaire part of the Very cool. Steve, where are you located at?
I live in a small town called Albany. That's Albany, California, which is just north of Berkeley. Okay. And I grew up in Southern California, but I ended up here because I went to school, graduate school at UC Berkeley.
Yeah, very cool. Very cool. Let's see. So it is May 27th as we record this, and I imagine spring is in full bloom in the Bay Area.
Yeah, we've had some actual pretty warm weather. It was, I was driving home from rainy, cool weather up in Seattle just a couple of days ago. And when I got to the Bay Area, I hit 100+ temperatures outside of the area where I live. I'm right along the bay, so the temperatures are moderated.
Yeah, a little bit. All right, very cool. Well, you got June gloom coming up soon enough, so we'll see. Very cool. I'm always curious how people get into astronomy. So how did you get into astronomy, Steve?
Well, I sort of had two different starts, I suppose. Okay. Kind of an early pre-start was in elementary school. I grew up in the late 50s going to elementary school, and I was fascinated by the beginnings of space exploration, satellites being launched, competition between US and Russia. And I used to keep newspaper clippings in a notebook of all the launches of the satellites, etc. Cool. I was very fascinated by it. Very cool. And I grew up not too far from Griffith Park Observatory in Los Angeles. My parents used to take me there, and I used to see planetarium shows. I found that just mind-blowing. And I actually started or tried to start a little astronomy club in the 5th grade with the kids on my block. And I sort of showed them my notebook of clippings from the Los Angeles Times, and I actually had bought some books on the planets and stars at Griffith Park Observatory, and I kind of had this idea I would teach them all about it in the 5th grade. Awesome. I think that lasted maybe 2 meetings or something before they were completely bored and wanted to go outside and play. Right. So that was kind of my early start. Good. And then when I was in my early 30s, I am married at this point. Okay. I discovered that my father-in-law had an old refractor that was in garage, unused. Okay. And I asked him, well, can I borrow that refractor if you're not using it? It was just a 60 millimeter, but I took it home. I lived in a reasonably dark area at the time. And when I got my first view of Saturn and the moon in that thing, I was hooked. Yeah, and off I went.
Very cool. Very cool. So time went on since you were 30, now that you're 32, I'll say.
Right.
What do you like to do in astronomy these days?
Well, I also, as I got involved in astronomy in the 80s, it was also the Dobsonian boom, and friends of mine were purchasing larger telescopes. And I quickly kind of escalated apertures from a 6-inch reflector, an Edmund reflector, to a Celestron C8 and orange tube C8.
Yep.
And pretty soon, within a couple of years, I was observing with first a 13-inch Newtonian, and soon after that, an 18-inch. So early on, by the end of the 80s, I was already observing with a fairly large telescope.
Yeah.
Of course, my main interest has always been visual, and I've always been interested in deep sky observing, particularly, well, the whole gamut: galaxies, planetary nebula, globular clusters, emission nebulae, anything particularly odd and unusual objects. I like to venture out of the mainstream.
Speaking out of the mainstream, that's a pretty awesome picture behind you. Where is that? What is that?
Well, actually, I took that photo during a hike inside Haleakala crater on Maui. And one reason I chose that photo, that's at 10,000 feet, by the way. One reason I took that photo is my wife and I are actually traveling back to Hawaii next week. We're leaving on Thursday to Maui. So I will be there in about a week. So it's kind of, I'm getting in the mood here.
There you go. Are you hauling your dog with you out there?
No. I have actually observed with some local amateurs a couple of times on the top of Haleakala. Oh, wow. There's a club on the island that does have an observatory up there, kind of alongside the professional telescopes, the Pan-STARRS telescope and others up there. Yep. And but no plans this time, just snorkeling and sunbathing.
There you go. There you go. Very cool. You probably have taken your scope out to several locations. Do you got any adventure stories from the field?
I have been fortunate. Well, I've actually, among the different activities I've done is I've hauled a telescope twice, that 13-inch travel scope all the way to Costa Rica as airline transportable luggage, and observed there a couple of times. Wow. And I'm really got the bug for observing in the Southern Hemisphere, or even though Costa Rica is technically at 10 degrees north latitude, it gives you a good view of the southern objects. And I've gone multiple times, both with my family, without my family, to observe in Australia. And I'm actually going back there. Nice. Hopefully, if countries open, etc., in October again. So I'm really looking forward. And this is purely an observing trip. So, and the opportunity to see the Magellanic Clouds, which is just something that has no parallel in the northern skies, is partly what's drawing me there. Cool.
I have been to the Southern Hemisphere 3 times, and every time I go, it's clouded out, and I have yet to see the sky from the Southern Hemisphere. So it's still on my bit bucket of things to do.
The 4th time might be a charm. You don't know.
We hope. We hope. And at some point, you started writing.
I started writing. I actually started writing for Sky and Telescope. I think my first article in 1999, and this was on Hickson compact groups of galaxies. So I've been writing pretty regularly for Sky and Tel for over 20 years.
Very cool.
So lots of articles.
So I'm going to find that Sky and Telescope article. We'll put a link to it in the description below the video. And speaking of galaxies and continuing your writing, we have this very awesome July 2022 article on the merging springtime spirals, and let's get together. And Steve, take us away.
Okay. Well, let me just sort of preface this by mentioning when I first proposed the idea of this article, it was a little different theme. I called it Close Buddies. And but I was, in my mind, I was just thinking of galaxies that appear to be close together in the sky. Those could be isolated galaxies where you just have a pair. They could be galaxies in clusters or groups or clusters where, of course, you tend to have some of the members pretty close to each other. But as I was kind of making up a list of these objects, I realized that in not all cases did I really know for sure, or astronomers didn't even know, whether the galaxies happened just to be lined up from our perspective, or they were actually physically close to each other. And that would be the case because either one or both of them, the redshifts weren't known. We didn't know their radial velocities. So it could be purely a line of sight superposition, and the galaxies really were one in front of the other. So, but I decided I really wanted to write an article about galaxies that were physically together. And that was the idea of let's get together. And the best way of kind of guaranteeing that they were physically together was in the case of merging spirals, because there's very dramatic physical evidence that the galaxies are in a process of merging. So first of all, I want to also say that galaxies really form by a process of mergers. It's not just that once in a while, two spiral galaxies happen to get close together like the ones that are in this photo here, but the Milky Way itself grew by a series of mergers. And we kind of know that because there are stellar streams of stars in our halo with common trajectories, orbits, and chemical properties that indicated they came from the same source, namely outside the Milky Way. And this happened in our past, but it's actually happening currently also. There's a galaxy that's not visible visually because it's hidden by the center of our galaxy, called the Sagittarius Dwarf Galaxy, or sometimes called the Sagittarius Dwarf Spheroidal Galaxy. And it's in the process of currently being shredded or ripped apart by the Milky Way. It's already deposited some of its globular clusters in the halo of our own Milky Way, which is actually thought to consist of up to a third of the globulars in our Milky Way are thought to have been essentially stolen from other galaxies, dwarf galaxies, smaller galaxies that merged with the Milky Way. But the article itself is going to focus on major spiral galaxies that are in the process of merging. And these are gas-rich galaxies. These are two sort of two galaxies right here that are stages of merging. We don't see them as a single galaxy. We see them separately. And astronomers have separated the merging process into 5 categories, which I'll just kind of quickly go over. So the earliest stage, which actually was the stage which that image showed, was called M1, merger 1. And in that case, the galaxies are on their first approach. And there's no obvious significant tidal features that we can see in the galaxies. As they move closer together, and by the way, I should say that sometimes there's more than one pass. There can be 2 passes or even 3 passes before the galaxies actually start to coalesce. But the second stage we can call an early stage merger. And just going through maybe the images quickly, where this sort of demonstrates that we can do that. The galaxies that are shown right there, that's an example of a early stage merger where you can see tidal tails and bridges. So we can see between these two galaxies on the left, that's a Hubble image, we can see a tidal bridge connecting the two galaxies. And that's typically seen in an M2 stage, merger 2 stage of the spiral galaxies. There's other things going on, but I'm just talking about what you can see visually here. The third stage, which probably is down on the next page here, and the third stage is where you're, let's continue down. In fact, let's go one more to the next page.
Sure.
Yeah, let's go up to the upper left corner here. The third stage we could call a mid-stage merger. And in that stage, you're actually, the disks themselves are going to be overlapping and merged. And sometimes, in general, there still are visible nuclei in the galaxy that are separate. So it doesn't appear as a single galaxy. And often in the telescope, you still can see two individual galaxies, but they might be in a common halo now. So we have two sort of cores, and they're surrounded by a common halo. Okay, and then let's move down. The next one may also be a mid-stage merger where the disks have now kind of merged together, but we still see tidal tails and features that are visually very evident in the middle stage.
Yes.
If we go down though to, let's go down a little further. Even this is another mid-stage merger in the upper right-hand corner where you can kind of see two separate galaxies. They can still kind of be made out, but they're obviously in a convoluted, contorted mess of a halo there. And we'll talk about this in a little more detail later on. Very spectacular. Again, these are all Hubble images. So, but these galaxies can be imaged by amateurs, and some of the features can be captured in amateur size telescopes. Now, this last one right here is an example of a late stage merger. Okay. Now, there's still some residual tidal tail you can see coming down, but now there's really only a single nucleus. If you look in the center there, you really just see one brighter spot there. Now the Hubble telescope, believe it or not, has resolved that one bright spot there into two nuclei that are only 1 arcsecond apart, much too close to be able to actually detect visually. But essentially you have a single visible nucleus and one glow, but you may still have some tidal features, which you can see there. And finally, I didn't include the last stage, which is called M5. I don't have a photo of that because I didn't describe an object like that, but that would be a coalescent merger. Two galaxies that have completed the process. Now the question is, what is that final result? And what we find is we end up with a spherical, or what would be considered an elliptical galaxy. Sometimes that elliptical galaxy will have an extended diffuse halo of stars that have been pushed out into outside the central regions from the merger. And sometimes there are very diffuse shells surrounding the galaxy that are visible on long exposure photographs, correct? But those features are really too subtle to detect visually and just take long exposures to bring them out. So the end result essentially is thought to be an elliptical type galaxy at the end.
Yep.
Okay.
Sounds like the merger. Just to give a shout out to Howard, you got a couple of Howard's drawings.
Yeah, we'll talk about those. Not only are they Howard's sketches, my descriptions in the article were made at the same time because we were observing together. So they were not done independently.
Cool. Okay. Okay. And we've actually done one of Howard's articles, so we'll put a link to that in the description.
Okay. So let me talk a little bit about, we could go back up to the beginning, but let me talk a little bit more about, briefly about the physical processes going on inside the galaxy.
Okay.
So as the process goes through these stages, particularly M1 and M2, the pre-merger and the early stage, gas from both of the galaxies are funneled towards the central part or the cores of the galaxy. Usually that takes place, it's thought that the galactic bars are involved in this process of funneling gas in towards the central parts of the galaxy. And this gas that rushes in towards the nucleus or the cores of the galaxy, it can ignite either a nuclear starburst, where a burst of star formation occurs in the core of the galaxy, and the galaxy core will brighten up noticeably. Exactly, that is a nuclear starburst going on right there in that galaxy. Exactly. The other thing that can happen is the gas can be funneled into an actively feeding supermassive black hole. And that triggers a AGN, which is an active galactic nucleus. And sometimes that active galactic nucleus, though, it doesn't necessarily show up on photographs because it can be obscured by, very highly obscured by gas. Dust, exactly. So the dust can obscure it, and because of that, we need to use other wavelengths, sometimes radio and infrared, to peer through the dust to be able to see what's going on in the cores of the galaxy. And so what happens next? Well, the resulting radiation, the optical and particularly ultraviolet radiation, gets absorbed by the surrounding dust and in the central portions of the galaxy. And that heat, that's re-emitted as heat by the dust re-emits it as heat. And what happens is the infrared luminosity of the galaxy can spike way up dramatically. And that's what happens in all of these merger cases. And there's a name for that. It's called, the galaxy becomes a Lurg, L-I-R-G, which stands for a luminous infrared galaxy. How bright is it in the infrared? Well, a Lurg actually has a technical definition. It's 100 billion times the infrared, the infrared luminosity is 100 billion times our sun's luminosity.
10 to the 11.
Kind of amazing. And all of these examples here are Lurgs. Okay. There's actually more extreme cases. And the last example I come to, I'll talk about that. It's the last example with this galaxy here that you're focused in on is called a Eulerg, U-L-I-G, U-L-I-R-G, which is an ultraluminous red galaxy. And that's 1 trillion times the sun's luminosity, or actually that can be, so what does that amount to? Well, that's actually 100 times the luminosity of the Milky Way just in the infrared. Okay.
A lot of light.
So maybe we can talk about some of these examples now specifically, if we can go back to the first one.
Sure, you want to start at the top? ARP?
Yeah. So this example right here, many of these galaxies that we're going to look at come from a couple of catalogs. One of them is the ARP catalog of peculiar galaxies. Yes, mentioned there, exactly. Another one is a Russian astronomer. The catalog is sometimes referred to as the VV catalog. I pronounce his name Boris Vorontsov-Velyaminov. Not sure I'm pronouncing
that was pretty good.
Okay.
That was pretty good.
There's a couple of other ones. There's another catalog called the Markarian Galaxy of Galaxies. Markarian catalog highlights galaxies with a ultraviolet excess. And so all of these are from those catalogs that I refer to.
Okay.
So the first one is called ARP 302. That example right there, those two galaxies, they have a single ARP designation. And to give you an idea, because it's hard to tell how far apart those galaxies are in the sky from the Hubble image, those galaxies are a little more than a half an arc minute apart.
Okay.
Okay. So fairly close together.
Yeah.
Oh, we'll get closer even as we move along.
Time goes on. Yes, they will.
Right. So
Not that we'll
northern galaxy there, it's Ultraluminous, and its luminosity in the infrared is 500 billion times our sun's luminosity. When I first observed this pair in my 18-inch telescope, and at magnifications under 200, I just saw a single elongated glow. That's how close they were together. They basically merged in my eyepiece view. They formed one continuous glow. But when I increased the magnification up to close to 300, about 280 power, I could resolve separately the two galaxies and even see that little star, which looks pretty bright in between the two galaxies, but it's a 15th magnitude star, and it's actually pretty dim in the telescope. That's how the Hubble kind of distorts our view of what's faint and what's bright.
Right.
Okay, so that's the only M1. Now, these two galaxies right here don't have any significant tidal features per se. There's no real strong tails, but if you look at the northern galaxy, I see some kind of gas maybe extending out the sides of the galaxy over there. And the bottom galaxy to me looks a little lopsided. The core of the galaxy looks a little bit off center, so to speak. So something starting here, but it's not too dramatic.
Right.
So maybe we can move to the next photo. And this one right here, and that has Howard's sketch next to it. This one is ARP 240. And ARP 240 is in Virgo, and it consists of two NGC galaxies. The one on the right is NGC 5257, beautiful spiral.
Yep.
And the one on the left is NGC 5258.
Yes.
Okay. Those galaxies actually are a little further apart, even though it's a stage 2 merger. They're about an arc minute and a half apart. I might say, well, why wouldn't they be closer if they're M2? But these galaxies are in the Virgo cluster, which is a lot closer than the other galaxies that we're going to be looking at in the article. So because their distance is much closer, the apparent separation is further apart.
Yes.
Exactly.
I'm with you.
So I have viewed this pair of galaxies. This is one reasonably bright. It is visible in a 10 or 12-inch telescope. It doesn't take a monster-sized telescope to view them. And you can see them as two separate galaxies.
Cool.
Even in my 18-inch, though, not much structure can you see. Both galaxies are clearly elongated. They kind of look like ovals up and down in that case. The one on the right is looks east-west elongated.
Right.
You can see perhaps some slight brightening, but really no features per se that are visible in that size aperture. But Howard and I often observe together with a friend who does have a monster-sized telescope in West Texas, in the shadow of McDonald Observatory in Fort Davis, Texas. His name is Jimmy Lowry, and he has a 48-inch
shout out Jimmy
telescope in a roll-off roof observatory. Wow. That is really observatory quality optics and telescope. Yeah. And it allows views that can approach photographic details in good conditions. Very cool. We happen to observe this pair together in just those conditions in the 48-inch. And that was, you may want to show Howard's sketch. Now, when you look at Howard's sketch,
Jimmy Lowry's,
and particularly the galaxy on the right there, you might think when you saw the Hubble image or even another photograph of it, that Howard just stood there and sketched the image or something. No, this was sketching the galaxy. And I should say how impressive this is, because we're way up on a ladder, climbing up, I believe it's a 12-foot ladder to get to the eyepiece. And he doesn't sketch the object down there. He has to put it in his memory, what he sees in the eyepiece, go down to the desk where we're stationed and sketch it from there without any preconceptions, without looking at the Hubble view of the what it looks like. And if you go back to the Hubble image, you can see how remarkably similar the galaxy appears through the 48-inch in Howard's view. Exactly.
Yeah.
So this is quite unusual. I do want to just mention a couple of features surrounding the core of that galaxy on the right. The brightest part of that galaxy, which is usually the core of the galaxy, really isn't in this case. There is a little small nucleus in the middle, but the beginning of those spiral arms on the Hubble image look very dramatically blue, and those are from newly minted massive stars that are shining very brightly. And in the eyepiece, if you look, those are the brightest parts that he sketched, and that's the way it looked. I describe them as looking like a set of parentheses surrounding the center of the galaxy. Exactly.
Yeah, very cool. Yes.
And inside those, the brightness dimmed dramatically, very quickly. So they were very thin arcs, and the reason they dimmed was simply dust that was lining the spiral arms inside those bright arms. We could see that faintly. We could see the tidal bridge connecting the two galaxies. You can see it on Howard's image, and the stretched spiral arms on NGC 5258. So it was really quite a special view to see those two galaxies. So once again, that's an example of an M2 merger.
Right.
Exactly. So I have one more M2 merger that it really has a exciting view in the Hubble image to me. So this one right here is ARP 238, which is in Ursa Major. And these two galaxies, the cores of the galaxies, again, are separated by about a half an arc minute. Now, to put that in perspective, what's a half an arc minute on the size? I could say, well, the moon or the sun is about a half a degree, so it's 60 times as large. But another way I find a little better way of thinking about it is these two galaxies are separated in the sky at about the same separation of the well-known double star Alburio in Cygnus. So amateurs who have seen Alburio the double star, the blue and gold double star in Cygnus, we'll have a sense of how far or separated those two stars are from each other. And that's how far the two cores of these galaxies are from each other.
Okay.
So you can see in this case, you can see the full force of the dramatic tidal arms and how they become distorted, particularly on that northern galaxy, right, where it has a tidal tail that goes to the north and then makes a dramatic turn to the 90-degree turn to the east. The bottom galaxy also has a tidal tail coming out to the right and then down where you have it pointed. Yep. And you can see new star formations, blue star formations, yep, towards the bottom galaxy. And I believe those blue stars kind of on the lower, exactly over there, to me, when I look at that image, it almost looks like they've been ripped out of the plane of the galaxy and are actually in a different plane now, like they've been literally grabbed and yanked out from the galaxy. And those two galaxies, once again, I have resolved them both in my 18-inch, but they're just faint blurs. In the 48-inch, we don't have a sketch by Howard, but we've also observed this together. Amazing. In the northern galaxy, the top one, you can see the tidal stream of stars coming up the north where you're pointing, and just the beginning of the turn to the left, exactly. Right. That part is visual, is visible. And on the bottom galaxy, you can see the tidal stream kind of going off to the right a little bit, like right there, exactly. And a very dim bridge between the two galaxies also. So not as spectacular as this image in a humongous telescope, but still quite dramatic.
Cool.
Okay, then we're going to go on our next one. Our next few examples are third stage mergers. And I believe we're just going to go in order here. The one in the upper left, that one is ARP 299. It also has an NGC number, NGC 3690, and it's in Ursa Major. This galaxy is actually the brightest galaxy in our sky in the infrared within 150 million light years. Okay. So didn't know that. If you want to consider that our local universe, sometimes astronomers consider up to 100 million light years our local surroundings. That is the brightest galaxy in the infrared. And you can see that frenzy of stars, and these galaxies have actually started to physically merge. They're connected, and right at the point where they are connected, you can see that frenzy of star formation right there. Exactly.
Gas compression.
Yeah, and all this activity, this nuclear activity, the AGN, and the all the stars that are new stars that are forming, bright new stars. What's the end result? Well, a lot of these are massive stars that go off as supernovae. So this galaxy has, since 1992, talking the last 30 years, has had 7 visible supernovae. Wow. Now, there could be other ones even that are obscured, that we haven't detected, that are hidden, behind dust. But there's 7 that have been physically observed in 30 years. And it's been a couple of hundred years since we've had one in the Milky Way. On average. This thing is really a supernova factory, this galaxy.
Very cool.
So this merger, by the way, the mergers happen on a slow scale. It looks dramatic, all this activity, but this merger began about 700 million years ago, actually. Okay, and a typical merger is thought to take place over at least 1 billion years. So this is well on its way to being merged, but it still has a ways to go. And, you know, obviously during our lifetime, all we can do is see snapshots of these different stages.
Yeah.
So this galaxy does have, it's hard to see it in this image, but there are 2 nuclei that are visible here. And there are the 2 nuclei are actually 20 arc seconds apart. One of them, if you highlight the real bright star formation, starburst region, right below it, right at the edge of it, right around there, there's a little bit of red there, and that actually is the nucleus. It's partially obscured, but that's the nucleus of that galaxy. And again, it's hard to see it on the one on the left, the Eastern Galaxy, but there's an area right around there. Exactly. That's exactly, you're pointing to the nucleus of that galaxy. And those 2 nuclei are, they're only 20 arc seconds apart. And I can, in my 18-inch, see both nuclei, 2 brighter spots within a irregular halo. Structure, but I can see it's not round. The two halos of the galaxies. So maybe we can move on to the next one, which is also a M3. Oh, I'm sorry. Let's go back up. We did. I think it might be the one on the upper right I want to talk about next. Yeah, that one. Okay. So if we can zoom in.
5256, famous one.
Yeah, that is an NGC galaxy. It's NGC 5256. It was discovered by William Herschel. And that galaxy is in Ursa Major. It's actually not that difficult to find. It happens to be only a little over 1.5 degrees northeast of the Whirlpool galaxy M51. So if you can find M51, this galaxy isn't difficult to find. It's kind of midway between M51 and Eta Ursa Major, which is the N star in the Big Dipper asterism.
There we go.
Okay. Awesome. So those 2 nuclei are only, right there, there's one, there's one. Those are only, it's a little very just, the scale is hard to grasp in the Hubble image, but they're only 10 arc seconds apart.
Wow.
They're very, very close together. Okay. And I could not resolve them in my 18-inch. I just see a single glow. But the 2 nuclei could be resolved separately, even at 10 arc seconds separation in Jimmy's 48-inch. So you can see that there's 2 galaxies there, but that irregular halo, you cannot see the fine structure in it. Now, obviously, there's something else interesting here, those reddish filaments coming out of the galaxy.
What are they?
This galaxy, the AGNs, these are dual AGNs, active galactic nuclei, they are driving a super wind that is expelling gas and dust from the galaxy out into intergalactic space. And so there's an intense outflow of the ionized gas, and that's what we're seeing in this Hubble image here.
Ionized hydrogen.
Yeah, exactly. Exactly. Okay, so maybe we can go back to that third M3 one that was down below.
Yes, that's a E705.
Yeah, so this one does not have an ARP designation. It's from that VV catalog, which actually is called the Catalog of Interacting Galaxies, appropriately enough. and it's VV705.
One.
And in this case, you can see we have there are two galaxies, clearly, because we see two very prominent tidal tails, one being kind of whipped around, maybe out the backside of the galaxy. And then there's one hook-shaped tidal tail coming down from the galaxies and then making a dramatic turn back up exactly to the north.
Yes.
And those two nuclei, which they're both in the brightest part that you see visually, right in there. The two nuclei in this case are only 6 arcseconds separation. Okay, very close. The two galaxies are almost over 500 million light years distant from the Milky Way, 560 million light years away. Okay, cool. And in my 18-inch, I just see a single glow. About the only interesting feature is that little brighter nucleus that you can see, the single brighter nucleus right there, is offset from the center. It doesn't look like it's in the middle of the glow that I see. But other than that, there's no other features. In Jimmy's 48-inch, that northern tidal tail you see just looks like a hairline curve emanating off to the right from the nucleus. Just looks like a thin arc going off to the right. Very, very interesting. And again, the bottom one is visible also, at least extending down as a kind of more of a diffuse glow. It doesn't have that thin, narrow appearance to it.
Okay, wider.
And so then we've, at this point, all of these galaxies I mentioned are called Lurgs. And we've sort of covered the M3 class. The last example we're going to talk about here is our M4 class. The M4, to remind you, are the late stage mergers. Okay. And this galaxy is Markarian 273, and that's also in Ursa Major. Okay, and again, we're looking at a Hubble image. The two in the center, you can see they have merged into like a single nucleus there. There is kind of a dim tidal tail going off to the left. You can just kind of barely see right, and a stronger, very sharply defined tail going down to the lower right from this galaxy. Now, this galaxy is, by the way, 3 degrees from Mizar, the famous double in the handle of the Dipper. And this galaxy also has a dual AGN. There are 2 nuclei, but they're not visible in this image, but they're both AGNs, and they're separated by only 1 arcsecond. So basically, they cannot be resolved other than, like a space telescope. And they're only 2,500 light years apart, the two nuclei. So there is a little brighter glow you can see right in the middle there, right? And there's 2 nuclei there, just 1 arcsecond apart, exactly. This is an example, this specimen is an example of what's called a Eulerg, ultraluminous infrared galaxy. And Eulergs have an infrared output of 1 trillion times the sun's luminosity or sun's output. Another way of thinking of it, if it's 100 times the entire luminosity of the Milky Way. And we only see Eulergs in M4 and M5 stages, towards the end of the merger, where the nuclei get real packed close together, and possibly their black holes eventually may merge into a single black hole. This is not the closest one. There's one Eulerg that's closer to us. That's an ARP. The number is ARP 220, and that's in Serpens. And that's the closest. It's about a half a billion light years away. This is the second closest. Markarian 273 is the second closest Eulerg. And Howard and I, you could show Howard's sketch here. Again,
very good.
Remarkably similar. Howard had no idea what the HST image looked like or any photograph. Partly the reason that's the case is we had no sketches or photos with us. We were, though, observing in with a fairly remarkable telescope. Sure. This was in 2019 in early May. And this was at the 80th anniversary of the inauguration of McDonald Observatory in Texas. And there was a lot of festivities going on. It was the same week as also the same week at the end of the Texas Star Party. And on a Friday night, Howard and I signed up we registered for 3 or 4 hours of viewing on the 80-inch telescope that was set up for visual observations. Cool. This was on a Friday night. They let participants in the Star Party observe Friday and Saturday night. And it was for 2 nights. But the festivities was all weekend. It included Sunday. Well, what happened was no one was signed up specifically from the Star Party to observe. Okay. So we got a call from the telescope operator, who just happens to be a friend of ours. He called us and said, well, would you guys like to come over after he was showing showing some objects to some of the members, some of the astronomers and dignitaries that were at the festivities at McDonald for the weekend. He said, would you, after that's over, would you like to observe on the 82-inch with me? Nice. So we had a private 3 hours observing with Jim Chandler, who's a local from Fort Davis, operating the telescope. And he basically said, well, whatever you want to look at, we can look at in the sky. Just Howard, myself, and Jim Chandler. Very well, good. One of the objects I chose was Markarian 273, which Howard ended up sketching. Very cool. You can see that nice. We could see the very irregular central portion, main portion of the galaxy, which Howard captured very well in his sketch up here. And the tidal tail, when I went up to the eyepiece, that was by far the most visually the brightest part that you could see of the galaxy. And there was kind of a little dim nucleus, but it wasn't very bright, but you could see a dim nucleus in the center of it. Okay. But extending down was the tidal tail, which to me almost just looked like a straight jet contrail extending, like the jet was the center part of the galaxy, and the contrail was extending down to the lower right. It was very well defined, and we were at such a high magnification that it extended across most of the eyepiece field. Okay, wow, cool. Yeah, so that was quite a dramatic view that I will always remember. That's a treat. That's a treat. Yeah. Not many people do that. I guess I'd like to just end this with one further thought. Sure. We're observing these galaxies that are hundreds of millions of, typically, the ones in this article are hundreds of millions of light years away. But the Milky Way itself is on a collision course with another major spiral, namely M31. Andromeda Galaxy. And it has been, that collision course will and eventually occur. It's inevitable, but there's no reason to be worried at this point because the two galaxies will not be in the process of merging for a few billion years.
Right.
But that process will eventually happen. And who knows, someone in some other distant galaxy might look back at the Milky Way and M31 and say, wow, look at the fireworks going on in those galaxies.
And they'll be publishing an article in their Sky and Telescope.
Right.
And they'll be your doppelganger over there, right?
Exactly.
Very cool. Well, yeah, a couple billion years will be really interesting because the two large local spirals will be merging. The sun will be expanding out into a red giant. It'll be a really interesting time.
That's right.
Very cool. Very cool. Steve, thank you so much for walking us through your very lovely article. I really appreciate it.
Oh, you're welcome.
It is cool. So I noted this that this article says springtime spirals. And so I'm wondered in the future if there will be a winter spirals, or since you're going to Australia and maybe there's an Australian sky and telescope, and I think there is, will there be a southern sky survey of stuff to do? So where do we go over the next, let's say 2 years or so?
Well, there may well be. I have actually written articles. I have written 1 or 2 articles in the past on interacting galaxies. I did write in Sky and Telescope. I did write an article on VV interacting pairs.
Okay.
And I think the name of the galaxy, the article might have been Galaxies in Collision. It was VV and ARP galaxies that were colliding. But I do like to I like to pick an eclectic variety of topics, observational topics.
Yep.
So actually my next article, which will come out next year, will be on discoveries of Williamina Fleming and Annie Jump Cannon at Harvard College Observatory.
Cool.
So all the various deep sky objects that they discovered while poring over the Harvard College Observatory photographs.
Yep.
And I also have another article that will be coming out next year.
Prolific.
That will be on local group galaxies in our local group, particularly dwarf galaxies.
Those. Very cool. You're prolific too. Very cool.
Well, yeah, it's an lifetime obsession. Let's put it that way.
There you go. There you go. Very cool. Steve, thank you so much for chatting. You're really wonderful.
Well, thank you very much. I enjoyed this.
All righty, and that'll do, everyone. And I hope this made your astronomy day just a little bit better. And we will see you on the next one. Bye-bye.
Bye.